Okay, so very excited to welcome Eric Siegel. Eric is a renowned expert in machine learning and is known for his ability to make complex concepts very understandable and engaging. And Eric will be speaking to us today about the AI playbook. So we'll hand it over to you, Eric.
Thanks so much, Amir. I'm going to focus today on predictive AI and why it's critical with predictive AI projects to not only evaluate the performance of ML models, but to evaluate them in terms of concrete business metrics like profit and savings. Usually not done, but very much needs to be. In 20 seconds, here's why enterprise machine learning is important. Business needs prediction. Prediction requires machine learning. Machine learning depends on data. Putting that in reverse, we have data, we give it to machine learning, and it generates models that predict. And those models improve all the large scale main operations that we conduct as organizations, which is why we call these use cases of enterprise machine learning predictive AI or predictive analytics. In that way, we boost sales, cut costs, combat risk, prevent fraud, fortify healthcare, streamline logistics, conquer spam, and win elections. As Morgan Vaughter put it in the of Unilever, put it in the foreword of my book, The AI Playbook, machine learning's practical deployment represents the forefront of human progress, improving operations with science. So in a nutshell, the machine learning method, predictive modeling method, takes as input that historical data and generates these golden eggs, which are the models that are then deployed and meant to improve all these large-scale operations across sectors, marketing, sales, fraud detection, all kinds of risk management, including credit risk, logistics, etc. But it turns out that the majority of these predictive AI projects fail to deploy. They don't capture value. The number crunching is sound, but they don't get operationalized. Many do. There's smashing successes, but more don't. One of the reasons for that is that there's no established, well-known business playbook paradigm practice that's well-known to business stakeholders about how to run these projects end to end. And I've developed one called BizML I'll talk about a bit. And within the auspices of that kind of playbook and that kind of business oriented process surrounding these projects, an often unanswered question is how good is the model? How valuable is it? What kind of business improvement in terms of KPIs and concrete business value like profit and savings it could deliver? These things often go unmeasured, rarely discussed in concrete terms, and that'll be my main focus today. So first, I'm going to just to make sure we're on the same page. Beyond my 20-second intro here, I'm going to talk about the value proposition, how it works and how it works to deliver value, improving operations. Basically as background info for about 5 or 7 minutes. And then I'll talk about the problem, which is that we as an industry, enterprise machine learning, predictive AI, are stuck on technical metrics of how good it is. This is what data scientists usually do: accuracy, precision, recall, area under the curve. They tell you very little to nothing about the potential business value in terms of profit and savings, the monetary value. We're going to change that, and I call it ML valuation. So that is establishing the monetary value before deployment and after deployment throughout the life cycle of these projects. So a few slides on about me. I'm the author of Predictive Analytics, which is a bestseller and has been adopted at hundreds of universities. And my more recent book, The AI Playbook, which presents that playbook practice paradigm, 6-step process called BizML, business practice for running machine learning projects successfully through to deployment. And I'll talk a bit about that today, but within that, I'm going to focus more on the metrics, the measures, making sure it works. Also, I've been running this conference series that I founded since 2009, formerly called Predictive Analytics World, now Machine Learning Week. Next one will be in June in Phoenix. And I'm the co-founder and CEO of Gooder AI, which is the business user console for predictive AI projects. I'm also a guy who skis. This is me, but unfortunately, this is the before picture and then the after picture. I had ruptured my anterior cruciate ligament, but the surgery was successful. The clinical outcome good, including what they call the knee walking test. Does it hurt to walk on my knees? No. The surgeon did a great job. Very important because I've got 2 toddlers. So don't feel bad for me. Feel bad for my insurance company. Knee surgery is very expensive. In fact, what insurance companies do, their core competency, their very central value proposition is what we can all do across industry sectors by leveraging predictive AI. That is to predict, forecast the outcome for each individual. Let's call these office workers cleaning the windows of a high rise as to the probability of a negative outcome. Eric Webster of State Farm said insurance is nothing but management of information. It's pooling of risk, and whoever can manipulate information the best has a significant competitive advantage. Again, same thing can apply outside insurance for pretty much any company. What we do with these models is predict these negative outcomes, both positive and negative. It's sort of this a semantics thing here, but just for the moment, talking in terms of the negative outcomes, what's the chance for this one individual that you risk them not responding after you invested $2 to market to them, that this individual will defect or cancel, that this individual will debtor will default on their credit, this individual will commit an act of fraud, any kind of outcome or behavior. So let's go to a more complete definition of machine learning. We're going to turn to this book. This is me reading the book to my son. He's a couple of years older now. Machine Learning for Babies and Toddlers. It's a real book. I do highly recommend this book for babies, but not for toddlers. You know, there's a lot of fuzzy definitions out there. Let's turn to this concrete, value-oriented, applied definition of enterprise machine learning, aka predictive AI. Technology that learns from experience. By experience, I mean data. Data is a recording of things that have happened in the past. It's a long list of prior events. It encodes the collective experience of an organization from which it's possible to learn, that is to say, to develop that golden egg predictive model, which then puts odds on, that is to say, predicts the outcome or behavior of each individual. So it's at that level of granularity. Individual could be a human or a corporate client or an item. So customer, patient, business, vehicle, image, piece of equipment, whatever that individual unit, that's the defining characteristic. Each individual gets a number, a predictive score. The higher the number, the higher expected chance the individual will click, buy, lie, or die, commit an act of fraud, turn out to be a bad credit risk, etc. Any outcome or behavior for which they'll be valuable for the organization in order to drive better decisions. And this last part of the definition is critical. That's the deployment part. That's where you're acting what you've learned on. That's where you've operationalized it. You're not getting value. You're not improving operations unless you change them. So by acting on those probabilities, those predictive scores, we're improving operational decisions, and in that way, improving operations. So in a nutshell, the data comes in from the left and the core machine learning method, the machine learning algorithm, the predictive modeling algorithm, same thing, does that number crunching and derives the model, which could be a bunch of business rules or mathematical formulas, lots of different ways to do it, which then is used in operationalization, in deployment, to score each individual for whatever the thing you're predicting for that project. So for example, with targeting marketing, you're looking at a customer saying, hey, should I expend the cost of contact? What are the chances if I do? There'll be a positive outcome and they'll buy our product. Right. So for targeting marketing, here's a few examples. First Tennessee Bank lowered the direct mail cost these are all examples of the improvement gained by using a predictive model, by using machine learning. They increased the ROI by a factor of 6 of their marketing campaign. Target, a big retailer in the US, does target their marketing, improved by 15 to 20%. Premier Bank Card, major issuer of credit cards, reduced their mailing costs and targeting their marketing by $12 million. But in more generally, across sectors, across functions, all of these actions or treatments done unto us by organizations as consumers dictate our experience in modern day society. And more, they are indeed making those decisions about these per case treatments based on the output of predictive models, based on those predictive scores. By doing so, millions of decisions a day are determined by those predictive scores by organizations of whom to call, mail, approve, test, diagnose, warn, investigate, incarcerate, set up on a date, and medicate. So that's the background. Now, here's what many people don't know is that the non-data scientist business stakeholder must delve into a certain semi-technical understanding for any given project and be involved on that level of detail across the project if you're gonna get it successfully deployed or operationalized. So often the number crunching is sound and that model just sits on a shelf and collects dust. Here are the 3 things you need to know. And if you're a data scientist, here's the 3 things your customer, your stakeholder needs to know. What's predicted, how well, and what's done about it, which are the technical terms for these by data scientists, are the dependent variable, the metrics, and the deployment. So that first and third, what's predicted and what's done about it, defines a use case. And the BizML practice I've been referring to, 6-step practice for running these projects, basically just has to do with unpacking those 3, not quite in that order, and then both pre-production and production, 3 and then 3 steps, total of 6 steps. And you can see how it plays out. But I'm going to focus mostly on the metrics. But just to make that a little more concrete, what's predicted and what's done about it? The first and third of that list of 3. So for targeting marketing, for example, you're predicting, will they buy if contacted? You have to be very precise about what you're predicting, what you're putting odds on with a model. And then what's done about it? Well, if they're more likely than some threshold to buy, expend the cost of contact, include them in a marketing campaign. Pretty straightforward, right? But you got to get involved with a certain amount of detail around that. Now, the third of these, of course, is how good is it? The value, the performance, both in terms of technical performance, pure predictive performance, and the business value, which is generally a missing step when you're running these projects, which is detrimental. And it's something that's got to change. You know, so these are sort of the main technical production steps of overall predictive AI projects. You prepare the data, train the model, deploy it, and then monitor moving forward. But after you've trained it, after you've created something, you should check out how good it is. You need to stress test the rocket and its intended usage according to the KPIs that matter before you launch it, right? Otherwise, if the stakeholders don't get their hands dirty, their feet will get cold. And that's what happens. These launches are routinely scrubbed. So that's what I'm going to be focusing on. So make it a little more concrete. The use case value proposition across all these different use cases, it follows the same pattern. It's about triage, prioritization across cases. So for example, when I used to teach, I would have people stand up. I have my students stand up and get in the order of the size of their television and hold a piece of paper with a number of inches of their television, and a 0 means they don't have a television. Maybe they watch on their laptop, and then I ask a yes/no question. How many people here have a subscription to Netflix? And this is the kind of pattern you tend to see across all these use cases, which is we don't have a magic crystal ball, but we have a lot more yeses than nos towards the top of the list, and then it kind of peters out. And you can imagine, of course, with a much larger data set, it's the same general thing. Lots of ones and then some zeros, and then by the end of the list, it's more zeros than ones, more nos than yeses. It's that straightforward. And then you just draw a line. So for example, if I were to market to something that had an affinity with subscriptions to Netflix, just to the top third of the list, I'd probably get a lot bigger bang for my marketing buck than to market to the entire list. So just driving that decision of who to contact or not, just put them in order and draw a line. Put them in order and draw a line. It's that simple. Here it is for targeting marketing. The upper line is profit. So as you go up, as you go down the list, again, from left to right, most likely to do whatever you're predicting with the model. And then we're going to use that to drive a treatment decision, in this case, whether to contact with marketing. So from left to right, more likely to buy if contacted, down to least likely. And then indeed, the profit tends to go up more steeply at the beginning, where you've got the higher echelons of people more likely to buy, but then there's diminishing returns because you've kind of exhausted those more responsive customers, and it starts to go down. So you're thinking, hey, let's slam on the brakes here, right? Let's draw this decision boundary and treat that, in this case, contact with marketing, everyone to the left of the dotted line. That's a decision boundary, and you can do that. But that's not necessarily the only right answer. It depends on the business context. Your stakeholder might say, well, this is a new product. We care more about getting the word out than immediate term profits. Let's draw the line here, where we essentially break even. Essentially, we can get marketing out there for free to this many, 74%, arguably a lot better than spending $550,000 to market to everybody. So you need to be able to visualize this, what's called a profit curve, very rarely done because the y-axis is a business metric. And as I'm pointing out, if you haven't been involved with these predictive AI projects, you may be shocked to know that generally they fail to estimate or forecast the business value in terms of profit, the monetary value, profit or savings or what have you, or whatever KPI matters to a nonprofit, whatever the organizational matters are. So here's a screenshot from our product, Gooder AI, that does exactly that. There's a profit curve comparing 3 models for targeting marketing. And let me just skip over to a quick different view just to make sure the concept is hitting home. I used Anthropic to make this little app, and here's the decision threshold. So I just want to be clear. Again, from left to right, most likely to buy down to least likely, or most likely to be fraudulent down to least likely. And you're drawing this decision boundary, and by going to the left, you're narrowing your target. Your target becomes more narrow. And if you go to the right, your target becomes less narrow. So you're contacting, treating, auditing, and blocking this many transactions, whatever the action that you're targeting. It's wider or more narrow, wider, more narrow. And again, from left, most likely or highest risk down to least likely. That's the pattern. And it generally applies to so many, because this is sort of the typical pattern for predictive AI projects. So here it is for targeting nonprofit fundraising. Taking a step back conceptually, let's talk about if it's risk because it's something bad you're predicting, like fraud. Right? From left to right, highest risk down to least likely. And then from left to right, how many are you treating? In this case, let's say we're blocking transactions that might be fraudulent from 0% to 100%. And on that scale, you're answering that question, you're drawing that decision boundary, but the y-axis should be a business metric. If it's cost, which is a negative, a bad thing, you want it to go down. And there tends to be this Goldilocks zone. The thing you want tends to be good some region more or less towards the center, or maybe more towards the left side sometimes, but and that's where you sort of peak. Now cost, if we just invert cost, it's basically savings upside down and vice versa, right? We've got Goldilocks skipping rope here, right? And indeed here we have it goes up and down. We've zoomed in here, so you're only seeing the top 8.6%. And we'll come back to this example, but this is for targeting blocking credit card transactions that might be fraudulent, and your savings, this is comparing 3 different models. Savings go up and down. You can see which model is probably the best. Of course, you're only going to block some small percent, some sliver of the most risky transactions. Decide which applicants for credit to approve based on credit risk scoring, which e-commerce shopping carts to block based on the risk, excuse me, that was the wrong word. Based which e-commerce shopping carts to offer a discount based on the risk from left to right that they're going to abandon. So more likely to abandon, that means they have a shopping cart, but they don't complete the transaction, down to least likely to abandon from left to right. Now there's some sweet spot, at least according to one of the models, tends to do well, and it improves your incremental revenue. Of course, you don't want to give that 20% discount if somebody is going to complete the transaction. So again, there's that sweet spot. There's that Goldilocks zone. Where should we spend human time auditing social media posts as potentially misinformation? Our company, Gooder AI, offers that interface to do that. Those were screenshots, and we have users now doing that for targeting email response, microloan risk decisions, collections paybacks, predicting who's going to pay back in order to target collections efforts. Targeting, it's sort of like targeting marketing, targeting solicitations for financial donations to a nonprofit, and separately different organization targeting blood donations, targeting solicitations for blood donations. Which dental patient is not going to show up for their appointment? It's kind of like an airplane seat. Should you double book this appointment, right? There's a downside either way. There's that sweet spot. You're playing this numbers game. You're calculating the odds at each case. Checking fraud. I talked about credit card fraud, similar with checking fraud. Customer attrition. It's called churn modeling. Who's going to cancel? Startup success to target in investments according to whether a startup is predicted as likely to succeed. I should say that these last 3 are just coming in now, but the other ones are actively used. So we're an early stage startup. So this sort of gives you a lay of the land. This is sort of representative of just how horizontal the field of predictive AI is in general. And we've got dozens more in the queue and in our funnel coming in. Oh, and predicting lawsuit settlements is also coming in. So a law firm can decide whether to take on a case. Okay, so taking a step back again, I just want to be clear. What normally happens is the data scientist gives the stakeholder just these technical metrics. Hey, look, the AUC, the area under the receiver operating characteristic curve, is 0.86. Isn't that great? And then the stakeholder, the person who asked for the model, doesn't get it because it's just a very arcane technical metric and doesn't tell you anything specific about the potential business value in terms of profit or saving or whatever the KPI is. Believe it or not, this is what happens, right? And people generally aren't translating or recalculating in terms of straightforward metrics. What do we expect the profit or savings to be if we deploy this model? So you can decide as a stakeholder, as an organization, and speaking the lingua franca of business, which model to deploy, how to deploy, whether you're ready to deploy at all, whether to actually operationalize. So this is what's generally called ML evaluation, and these technical metrics are important, but they only tell you the pure predictive performance, the performance of the model, relatively speaking, compared to random guessing or some other kind of baseline like that, which is good to know. It's better than guessing, and it's typically all that we can hope for because we don't have a magic crystal ball. We know that therefore it's potentially valuable, but we don't know how valuable it might be. That's ML valuation. So we call it not ML evaluation, but more specifically valuation, that is in terms of business metrics like that relate to the monetary value or whatever the KPI that matters. Right? So the state of the art, according to our and other industry surveys, is that most of these projects fail. And even though there's general consensus that technical metrics have this limitation and they're not what you need. For example, Harvard Data Science Review said that these metrics are fundamentally useless to and disconnected from business stakeholders. And in fact, our industry research, one survey showed that even the data scientists are saying, look, we understand the metrics of the business metrics are most important, like the returns, the revenue. And yet, when asked which metrics they tend to use more, it's these technical metrics: lift, area under the curve, precision, recall, even accuracy is only a technical metric. Part of the problem is, the challenge is that when you look at a predictive model, this is a decision tree, but whatever the model is, you can't just say, hey, that thing's worth $1 million. When you want to turn to business metrics like profit, it depends on how you use it and depends on the business context. So it kind of opens a can of worms, but a can of worms that's got to be opened and dealt with. So this is what our solution at Gooder AI does, which allows you to create a profit curve where the y coordinate is a business metric or whatever metric you want. It's very configurable. As you move that decision threshold from left to right, you can compare all these different metrics that are maybe competing KPIs. You can parameterize it according to any business factors that are subject to change and uncertainty, and there generally are some, which will change the shape of that curve and change the story to deliberate these decisions about deployment, and then of course change them. So let me just jump to what the product actually looks like. So here we are targeting fraud detection. So deciding based on the risk from left to right, most likely to be fraudulent down to least likely to be fraudulent. How many shall I block? We're generally only going to block as a bank the top few percent at most of credit card transactions that might, and this is a use case, by the way, where predictive models are used in real time without a human in the loop, right? So it puts the risk score, and that's used to directly make an immediate decision of whether to approve and authorize the transaction. So within just sort of the top, I've zoomed in to the top 6%, and you can see that it peaks around here. I can say, okay, look, here's where it peaks. But of course, the shape of this curve depends on, what's that? Let me try that again. Zoom out and then zoom back in. The shape of this curve, the story it tells, and informing those deliberations of where to draw this decision boundary depend on factors such as, in this case, what are called the false positive and false negative costs, written in English, cost of wrongly blocking a transaction. You've inconvenienced a legitimate cardholder. But that can be annoying, and they might start using a different credit card, and the industry standard may be around $100. But you might say, hey, look, every time we do that, and we find out later, let's send them a $25 gift certificate, and that might on average decrease the risk down to 75%. So you need to be able to change and interact with this kind of, it has to be a GUI. And that's why we created this product, is you got to be able to interact and say, okay, how does that factor, which is subject to change and uncertainty, influence and change the shape of the curve, the whole overall story, right? Or fraud, high value fraud might be increasing. What would happen if it went up to $600? Same thing. You need to be able to move these things and change them. Okay, so let me just wrap up with a few more concepts about all this. First of all, we added a chatbot. So there's really two business advantages to this type of solution, where we've made the much needed move to valuation, to business metrics, not just evaluation technical metrics. One is that we can actually create a useful model, right? The model development practice done by data scientists, where they're train test, you're only typically testing in terms of arcane technical metrics, but if you don't measure business value, you're not pursuing business value. How do you know you're navigating that model development practice towards value? And then secondly, how do you bridge the gap to your stakeholder who wants to speak the language of business, the monetary value or whatever KPIs there are, right? So in the realm of bridging that gap, we added an LLM chatbot with like a bunch of specialized prompts and such. So let me show you a 20-second. So you can see there's a chatbot on the right. You can ask it any questions. Well, what if I move the lever here? What if I change this threshold? You could, what do you recommend I do? Right? It serves as a thought partner and co-pilot, like an autonomous virtual data scientist. So stakeholders can ask questions ad infinitum. So here's, I'll show a 1-minute video where I've asked it, hey, why does the curve go up and down? That is to say, why is there that Goldilocks zone effect? So let's just watch that 60-second video.
Explain that for a 10-year-old using a story.
Let's imagine you have a lemonade stand and you want to make as much money as possible. You have a special machine that can predict which kids walking by are most likely to buy your lemonade. At first, you use the machine to call out to the kids it says are really likely to want lemonade. Since these kids really want lemonade, most of them buy from you and you make good money. But as you keep calling out to more and more kids, eventually you start calling kids who don't want lemonade that much. Some of them buy, but many don't. And for every kid you call out to, you have to use your allowance money to make the lemonade. So while you make some money from the kids who do buy, you're also spending money on lemonade for kids who don't buy. At some point, you've called to so many kids that you're spending more of your allowance making lemonade than you're making from the sales. That's when the profit curve starts going down. You're losing money by calling to too many kids.
So I meant to disclose that we don't have speech synthesis, so that was added to the video after, but everything else operates as you saw. And in general, we're soliciting early access trial users. We've got a lot under our belts. It's going very well, but we would like some more. So if you're interested in trying this on your predictive modeling project or asking any questions about it, please reach out to us. You can go to our website, which is Gooder AI, and see that video as well as a couple others easily accessible right at the top of the video at gooderai.com. So to wrap up, right, if you're not measuring business value, you're not pursuing business value. And that's why it's critical to move to ML valuation in these predictive AI projects, in addition to the more general established practice of evaluation in terms of technical metrics. I also wanted to remind you of the conference again, which will also be in November in Berlin. Our June event is set to be very much a hybrid event. So there's predictive AI, it's about half and half between predictive AI and generative AI. And in fact, we have an entire track devoted to hybridizing between the two, where predictive and generative are basically just two categories of machine learning use cases. But there's ways in which they kind of both apply at the same time. One is the chatbot you just saw, helping guide a predictive AI project. The other would be using predictive as a layer on top of generative to help improve its autonomy. Because right now, can you trust it? Well, have a predictive model answer that question so that you can viably deploy it and achieve a great deal of the often hyperbolized promised autonomy of generative AI.